Hi everyone, this is the 12th video, guys, of me tackling the 12 promised question paper questions. Ne? Just click the link on the description below. It will direct you straight to the playlist where I answer all the questions. And the second playlist is for those who still want to learn vertical projectile motion from scratch. You know where you are with regards to understanding. If you feel like you still want to learn, please click the other video. But if you feel like you wanna apply the knowledge you have, just click the playlist with me answering questions. Okay. We are told that ball A is dropped from rest from the top of a building which is 15.2 meters high. After ball A has fallen 3.2 meters, a second ball B is projected vertically upwards from the ground. After a while, the two balls strike the ground at the same time. We must ignore the effects of air resistance. Okay. The first thing we need to do, we must define the term free fall. Free fall is when an object is moving. Free fall is the motion of an object which is under the influence of gravitational force only. And then 3.2.1 must calculate the time taken for ball A to strike the ground. For ball A to strike the ground, the initial velocity of ball A is 0 meters per second. Why it was dropped? I don't know the final velocity. I'm looking for the time it took. Displacement, that's 15.2 meters. But remember that, guys, displacement is a vector quantity. So I need to assign it direction. Let me take it downwards movement as positive for now. Let me declare downwards is positive. I've been taking up as positive for a while. So now downwards is positive. So this thing, since it's being displaced downwards, delta y will be positive. For the fact that I've chosen down to be positive, the gravitational acceleration will always be positive. So I'm just looking for I just want to find the time. The time it took the ball to reach the ground. I must simply use any equation that doesn't have a final velocity, because I also don't have a final velocity. So I'm going to stick with equation 3, 1 over 2 g delta t squared. I have 15, 0 multiplied by delta time plus 1 over 2, 9.8 times delta time. 15, that's 4.9 delta t squared. I'll therefore put everything under the square root. I'll simply get let me punch my precious calculator. 15 over 4.9 all over. Okay, therefore the change in time is just 1.75 seconds. So the ball will strike the ground after 1.75 seconds. Okay, and then now must calculate the magnitude of the velocity with which ball B was projected from the ground. Okay, remember that ball B was projected after the other ball has fallen for 3.2 meters. However, ball B and ball A will reach the ground simultaneously. Okay, let's find out how long did it take ball A to drop for 3.2 meters. How long did it take for ball A to drop for 3.2 meters? Displacement now changes to 3.2. Displacement changes to 3.2. So therefore our change in time will be 0.81. Okay, so ball B, therefore the total time for ball B to be in the air, it was just 1.75 minus 0.81. 1.75 minus 0.81, that's 0.94 seconds. Remember that, guys, both balls will reach the ground simultaneously. However, ball B was thrown upwards after 0.81 seconds. So ball B will take lesser time to be in the air as compared to ball A. Are we together? So I now know the time it takes for ball B to be in the air. So let me illustrate motion the ball B. Let me do it there. And ball B will move from the ground, reach maximum height, and then come back to the ground. The total time it will take, that's 0.94 seconds. If the initial velocity of ball B is x, it simply means the final velocity will be negative x. Are we together? So now they just want us to find the value of x, basically, which is the magnitude of a velocity. I can call this point P, Q, and R. If I'm looking at path PR, path P to R, the initial velocity is x, the final velocity, that's negative x. Oh no, remember that, guys, I said downwards is positive, so the signs have to be different here. If this thing was thrown at a velocity of negative x, it must come back at the velocity of positive x. Remember that downwards is positive, so everything that goes up has to be negative. So it's negative x and a positive x. Delta y, it moves from the ground and then comes back to the ground. So delta y is just 0. The time it took, that's 0.94 seconds. Gravity, that's positive 9.8 meters per second squared. So they want me to find e velocity, the initial velocity. I can use any of the equations here, guys. The easier one is to use the first equation. Vf is equal to Vi plus G delta T. The final velocity is x, initial velocity is minus x, right? Plus (9.8) multiplied by delta t, which is 0.94. So whenever I take the x to the other side, I'll simply have 2x. This is equals to 9.8 times 0.94. Divide both sides by 2. I'll simply have 9.8 times 0.94 all over 2. Then x will be equal to 4.61 meters per second. So that will be the magnitude of a velocity. So the magnitude of the velocity is just 4.61 meters per second. Okay. On the same system of axes, draw position time graphs to show the motion of both balls A and of ball B. Okay. We must take ground as the reference point. Remember that ball A was thrown. Was thrown from a height of 15.2 meters. And and then ball B was thrown at the ground after 0.81 seconds. 0.81 seconds, and then it traveled, reached maximum height, and then came back. Let's say it traveled, reached maximum height, and then it came back here. The total time was 1.75, and then the other ball who it moved like this, they reached the ground simultaneously. So this one represents ball A, and then the blue one represents ball B. All together, you'll obviously write the heading, position, time graph, and then on the y-axis you'll obviously say this is the change in displacement in meters, here the change in time in seconds. That's how, guys, you could have drawn your two graphs now. Yeah, so this is how, guys, you're supposed to tackle this question. Yeah, and I really hope that, guys, the videos helped you out. If there are things I'm still not sure about, please do ask. You can either ask me or write on the comment section. I'll definitely come back and assist you. Thank you very much, guys.